So we are going to deviate a ray of light through 60 degree by total internal reflection, which can be done with the use of an equilateral prism. So the first thing, we have to draw an equilateral prism, or a side of it, which we do, cross section of it, which we do to depict the deviation. So this is the cross section, 60 degree angle. Now we direct an incident ray from this way. This is the incident ray. It strikes the surface at an angle of 90 degree, and so it passes undeviated this way. Now from here, what will happen is at that surface you have to draw a normal to the point where this ray is hitting the second surface. So I drew a normal. Now what we will do is that we have to find out what angle is this. What is the angle of refraction over here? Or we can say the angle of incidence, because here the total internal reflection is about to take place. So this will be the incident ray and this will be the refracted ray. So this is 60 degree, this is 90 degree. So the total sum should be 180 degree. So this will be 30 degree. If this is 30 degree and the normal is forming 90 degree, with the surface. So if this is 30 degree, then this will be 60 degree. That's what you have to mention, 60 degree. Now the angle of the critical angle for a pair of media, here in case of glass and air, is 42 degrees. So obviously 60 degrees is greater than 42 degrees, so internal reflection will occur. Now that means that the reflected angle will be equal to the angle of incidence, this way. So this was our incident ray. It passed undeviated. It struck this surface. We came to know that the angle it formed was 60 degree, which was greater than the critical angle, which is 42 degree for glass and air medium. So it will suffer total internal reflection, and the angle of reflection becomes 60 degree again. And here again it is forming an angle of 90 degrees, so it passes undeviated. Now we take another ray over here. Now this ray, it strikes the surface over here. We are drawing the normal at this point. And when we consider this triangle, this is 90 degree. When we consider this triangle, this is 90 degree, this is 60 degree. This is 90 degree because the normal is forming this angle with the surface AB. So this one is, if this is 60 degree, this is 90 degree, then this is 30 degree. If this is 30 degree, then this angle will be 60 degree. Once again, this angle is 90 degree. Why? Because the normal is drawn perpendicular to the plane where the incident ray is striking. So if this is 90 degree, this angle is 90 degree, this is 60 degree, then this will be 30 degree, because the sum of angles in a triangle is 180 degree. Now this one is supposed to be 90 degree again because the normal is drawn perpendicular to the surface. So if this is 30 degree, then this is 90 minus 30, 60 degree. That's what I've written. Now again, it's greater than the critical angle 42 degree. So again, it will suffer reflection by an angle equal to the angle of incidence. So it will go this way. So this ray entered this way, and it passed undeviated because the angle it formed here was 90 degree. Then it went this way, suffered total internal reflection, goes this way, again it forms 90 degree here, so it passes undeviated. So that's it. This we are considering the incident ray. This is the emergent ray. Once again, incident ray, emergent ray. So I'll name it to PO, PQ. Here is your incident ray, which goes through this prism and it emerges as ST, which is the emergent ray. And so the rays have always, whether we consider this ray or this ray, in both the cases it has been deviated by an angle of 60 degree because it was deviated by an equilateral prism. So this is how you can draw the diagram, not by learning it but by using your logic at each turn to find out which angle should be where and how is it going to deviate.